So here we have which of the following is the inverse of y is equal to 6 raised to the x power. Inverse, we can switch the x's and the y's. So this would be x is equal to 6 raised to the y power. But this is not what we want. We want to isolate the y because that's all our options. All our options are in that form. And so what can we do to get it to that form? We can do log base 6 of both sides, right? We can do that. Okay. So log base 6 of 6y and then log base 6 of x. So log base 6 of 6y, we can use the property that puts y forward and then makes this log base 6 of 6. I actually made a separate video on this. I have a separate video on this log property. It's a very nice property and it helps you a lot in many different ways. So make sure to check that video out if you don't know this property. Anyway, what we do is then we divide by log base 6 of 6, right? 6 of 6 log base 6 of 6. And so this would cancel. So y would be, I'm just switching the order, would be equal to actually just log base 6 of x, because log base 6 of 6 is this is actually all equal to just 1. Because think about it, right? Log base, if we think about it here, in case you don't know the property, if we think about this thing right here, then 6 raised to the y must be equal to 6, right? This raised to this must be equal to this. So 6 raised to the y is equal to 6. What do you raise to this base to get the same number? What do you raise to a number, right, to get the same number? It has to be equal to 1, right? C has to be equal to 1, so y has to be equal to 1. So this has to be equal to 1. So log base 6 of x is your y, which is actually your inverse. So this is actually your inverse function. And so your answer would be this one right over here.